I still believe that it's important for the human brain to do stuff that is hard. You always need to try to improve on what you're doing. And specifically when you're young student, you should be learning stuff.
I think that what's great about those tools is that it can guide you like a mentor or a tutor to achieve what you're trying to do faster. And so if I can do more things in less time, then I can extract more learnings. And so I think that the way I would approach that is, what is my goal? Welcome everyone, this new episode of Let's Talk. I'm super happy to be here today with Remi Fabre. Remi, how are you doing?
I'm fine. I'm here with Rémi, the short dance for you.
How are you doing? This is so cool. This is an awesome way to start this episode. Excited to have you both on the podcast. This is the first time where I interview Reachy and Remi. Okay, so for the people who might not know you, what would be like 3-sentence at a conference description that you could do of yourself? And then I can do like mine while I'm watching Reachy going wild.
At a conference, I don't know. I think when people meet me, like after a week, they'll say I'm passionate. But after a year, they'll say I'm exhausting.
Obsessive. I love obsession.
I'm a robotics engineer. I've been curious about many things. I've played around many different technologies, control theory, navigation, grasping. I think something that's special about my career is the amount of robotics competitions I've done, always with teams, of course. I think it's more like almost 15 iterations of competition. Every year I get into one thing or another. I'm generally passionate about learning stuff and then teaching about it, building something with it and then teaching it. I've been teaching higher education for 11 years.
That's super cool. I'm so excited. So within the topics that I want to discuss, I definitely want to discuss robotics itself and your experience with it through the years. You have a YouTube channel that has a lot of videos. Some people might have seen you in recent videos that you shared on LinkedIn with Reachy Mini. So we're going to get back to that. Maybe just to make sure that we understand what you're currently working on. So you're currently working at Poland Robotics. Can you share more about how's that work, the recent collaboration with Hugging Face, the soon to be released very cute robot that we have here with us? So can you share a bit more about all of that?
So I've been working at Poland for close to 4 years now. And something very special about that company is that we do open source, even for hardware. So open everything, which is a bit weird because when you're making robots, it could be perceived as risky to just provide everything as open source. But I really like that philosophy. And I do believe it also has perks from the marketing side because people tend to trust you more because everything is public. You can review whatever you want. And if the company closes, you can always maintain the repos and everything. So I think it's a very healthy way to move forward. Yeah, we built different robots, Reachy 1, various iterations, and Reachy 2 will be a bigger one to armed model base and 3 kilograms of payload. I worked on that robot for like 2.5 years. And then recently, a few months ago, Hugging Face acquired the company. And something I really appreciate is that I think we have a common vision of open source. They do everything open source. Well, that's their thing. So it was a very natural marriage, I think. Reachy Mini emerged from that, was the first big project that came after the merger or the acquisition. Super excited about the project. We've been working like crazy on this. We had a first version that worked. At first, we wanted to sell just a small amount, maybe sell 1,000 over the course of the year. We sold 8,000 in the course of the day. We had to handle mass production issues. We'll be a bit late to provide the robot for everyone. But as far as I know, all of the hard technical problems we had with this are now resolved. And I do hope this is a very high quality robot.
Just before I dive into a series of questions that I have regarding the open source repo, how you're building this, how does it work, the acquisition by Hugging Face, and like how do you work internally working on those robots? But before that, I think that your team are actively looking for senior robotics people to have early access. Is that correct? Should people reach out to you or to the team, like if they have like the expertise to be building with an early version of Reachy Mini?
Okay, so you're referring to the beta program we started with Reachy Mini. I think we're all set up with that because we have a Discord channel and all the people that were interested in robot just got there. And then what we said is we're making a small batch of robots that we'll send to the very first buyers and some VIPs that we think are good testers for the robot, like makers and experienced people. What we want is for them to test it and find bugs and find pain points and what works and what doesn't. So we could improve before the thousands of units are shipped all around.
So exciting. I want to deep dive into your curiosity and maybe obsession to some about robotics. I'm not saying this in a negative way. I think that obsessions are awesome. Just before that, can you share an example of a very interesting bug or something that you fixed with the team on Reachy Mini? What kind of problems can come up from users using it that you have to fix?
Have you seen the conversational demonstration where the robot talks and analyzes stuff and everything?
Yes, and it will also be in the links in the description of this podcast so that everyone can see these demos. Yeah, go ahead.
When you build something like that, you need to be very careful on how you handle synchronicity of events. You've got the model that provides audio output that you need to play, and you're providing it like image, and then you need to start a movement. You have a control loop that needs to be very clean. That's the perfect playground to create racing conditions. We've had a few of them. Something I'm excited about this is to hopefully show a good way to build software for robotics specifically, because there are types of problems that are just terrible if you didn't understand them well when you're doing robotics. Everything that has to do with handling the input outputs, like how do you read the camera, how do you read the sensors, how do you handle timestamps? That's one of the subjects I think are important to understand. In robotics specifically, the continuity of movement is important. But what's not cool is to have a brutal change of movement. And if you think about the way you can define the movement of like the head, how many numbers would you use to define the position of the head?
Like how many positions can the head have?
No, how many numbers would you use in your code to describe the position of the head?
Oh, I have no idea, but I would assume that it's a big number that will surprise me. How much?
No, well, okay. So the trap I was setting up is like typically someone will think about the X dimension,
okay,
the Y dimension, and the Z dimension, right?
Okay.
So the typical answer I get in robotics class is 3 dimensions, right? But when we do that, we forget about the rotations, right?
Okay.
So when we define the pose of the head, we are actually working in, well, that's what we call the task space, which is something we define for a given robot and a given task. But typically for this robot, the task space would be the pose. That's a 6-dimensional thing that describes where the head is in space. It's very important to be able to do continuous movements in task space. And to achieve that, well, you need a series of things that work properly. The first of them is the inverse kinematics. I don't know if you're familiar with that.
I'm not.
Is it okay if we talk about that? It's a bit technical.
Yes, please. Go ahead. I will have many follow-up questions.
Okay. So when you have a robot, you have actuators, right? You have stuff that can move. We call that joint space. The joints, you can control them, right? And that's the simplest thing to move. Like you have the motors, you can provide goal position and they move. If I can show the interior of the robot, I don't know if you can see it, but yes, this is what we call a steward platform. It's a bit weird because the head is connected to 6 different motors, and the combination of the angles of the 6 motors will provide a position of the head, which is very weird. We call that a parallel system. But if I gave you this robot and I just gave you control of the motors, you wouldn't be able to do anything that's remotely useful. Like that. Because controlling the motors directly has no direct and easy, obvious impact on the head. Like you could move a motor here and it will go like that, right? The mathematical function that goes from moving something in motor space to having a pose in task space is called the inverse kinematics. And well, the other way around, when you know the position of your motors and you want to get the current pose of the head, that's called the forward kinematics or direct kinematics. Well, that's one of the use cases I'd like to use this robot for is a robotics class, because you can sometimes you do that with an entire robot arm and you do drawings. But I think with this one, since the robot is cheap, you can manipulate it. You can fill, well, maybe not fill all of the equations, but at least some. Yeah. So okay, you need to have the inverse kinematics that works properly. A control algorithm typically on top of that spams continuous commands. And then when you're doing your application code, like for example, the dances, you need to make sure that at all moments you have a continuous command in task piece. So you've got the pose as a 4x4 matrix that has to be continuous in X, Y, Z, wall pitch. Are you familiar with wall pitch? I don't know. This is the name we typically give to the orientations like wall, pitch, and you. Or it's just a convention if you use Euler angles. It's very easy to make this in an improper way because you're thinking about a behavior. That behavior is continuous, like a dance or something. And then you swap to a different mode. Like, oh, I have a breathing of the robot so that it feels alive. Oh, I have face tracking. Oh, I want the head to wobble when it speaks. You need to combine all of these so that at the end, doesn't matter, the movement has to be continuous. Once it's done, it's relatively easy, but I think it's easy to mess up. In some rare occasions, I mean, I absolutely despise discontinuities when you have a robot arm that can be dangerous. On some rare conditions on a robot like this, that's safe by design, a discontinuity of control for the head can be okay because it can be like see surprise and move. But when it happens on the antennas, I don't like it. It feels like it's a bug.
That's awesome. That's so interesting. Okay, so I do want to do a deep dive into your learning curve with robotics because I'm very used to web apps setup and frameworks and logics, but I am quite a beginner in like the robotics world, which I think is great because I can ask interesting questions, I guess. The first one that comes to mind is when you're teaching, because you're also an educator on that topic. So you mentioned a few concepts. I really like them. What are the common thematics that you find yourself explaining over and over? Are there like specific interesting concepts around or about like Reachy Mini? Because the way I see it, just speaking of Reachy Mini, it's an extremely interesting robot based on those 6 axes that you were mentioning so that you can really play, for example, wiggling the head and having the robot say something at the same time and maybe like create some more custom systems so that
like face tracking, you can face track it at the same time.
And could it, for example, face track wiggles, but based on the direction of the conversation and some API calls, then you like animate it. And if you're mean to it, then it goes into a motion of more slow, sad movements.
The answer to that is yes.
So can you tell more on that? Like, how does it work? Because I think that the dream of, okay, correct me on that, but I think that is the dream of anyone building robots is like to have your personal robot following you and doing stuff for you. Is that true or is it just me?
I think that's a common objective. I wouldn't say it's the objective of everyone, but I think it's a common one.
I guess that this is the same thing. You have that idea of a robot, but then you spend more than 10 years with robots and you see it totally differently. Maybe before answering the educator question, what's a big motivator behind you building robots? How do you keep that interest through times? Because you've built many robots, many kind of robots, worked in many teams doing robotics. So what is your curiosity and passion for robotics comes from and how did you grow it through time?
That's an interesting question with many answers. I think what currently drives me is that there is a kind of a multiplicative effect of the impact you can have. Like if you build a great platform like this one, and many people use it to, even if it's not directly useful and they learn something thanks to that, I will be incredibly proud of that. And this robot, compared to the previous ones where it was more, let's say, task-oriented, you had to grasp something, the navigation had to be very accurate and stuff. This one has a lot more emphasis on interaction with people. And every time I see like a kid or something interact with the robot and they light up and they want to play with it, I feel great. There's a combination between science, technique, and a bit of art that I find very, very interesting. We are at the beginning of this project, and I really want to know what happens when thousands of people play with it. What will they invent? Like when I had it in the first months, I was like, one of the side projects I did is like, I take the head and I use it as a music instrument, like as the inputs of a music instrument. So that, for example, do you know the theremin? It's a very weird music instrument where you go like you move your hand and it creates sound.
Yes.
Yeah?
It's like a
Yeah?
piano, and you have a little antenna, and then
Yeah,
based
if you
on
have
where you
antenna.
place your
Yeah,
hands, it does
exactly.
a wave sound that is like
Yeah.
a high pitched sound that is very beautiful, and then you can move throughout the tonalities with it. Yeah, I love that
Beautiful or
instrument.
not, I've seen
And
some very excellent musicians that can do stuff with it, but I think if I play it, it won't be. It won't be. So yeah, since we have like the number of control dimensions we have is 9 because we have the 6 from the head, we have the body that can rotate like this, and we have the 2 antennas, right? So I did something where the angle of the antenna chooses the instrument, guitar, piano, or whatever, and the angle of the head shoots a new note. Of course, I'm no musician, so it sounds terrible, but I think with some iterations, it could become something that works, maybe. I tried to make it into a chess companion that looks at the board and tries to provide guidance. Something I like to do with these robots specifically, since we are the era of AI agents that are surprisingly smart and capable, is to give the robot a personality that is not always super like clean and I think it's fine that the full personality is always happy and polite and stuff, but I've had a lot of fun making the robot a bit angry. Right. For example, this one is angry because he wanted to be a Mars rover, and he's an open source robot that doesn't have legs, and 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 angry because he's exhausted and annoyed by the amount of bugs I would put into his code base. And every time I push something, he's like, "Oh my god, what did you do?" And I think playing with the boundaries of what's a normal robot behavior is very fun. Should be also a subject we should be careful about. Like, I don't know if you follow what happened when OpenAI released GPT-5 and GPT-4 disappeared. And the amount of people I saw on Reddit being lost, that they lost a companion, that did something for me. I was like, okay, a lot of people connect to AI models in a way that I didn't anticipate. And this robot is that plus something that's cute and has a physical presence. I think it's our responsibility to be careful with that. But at the same time, we provide mainly the machine and we provide everything as open source. So everyone will be able to do whatever they want. The amount of control we have is limited. I think it's something we should be careful, but
you mentioned many interesting points, some that goes into like a deeper thing. So we'll get back to that. I'm curious to ask you about, because when you think about Reachy Mini, for example, it's an awesome companion. I could really see it on my desk doing things for me. Hey, send that, or like do this, kind of a custom Alexa or something. But I don't know. This is debatable, but you know, when you have a dog and the dog is like having emotions, and it makes your day different in some ways. And I think that having those reflections of ourselves that have personalities gives texture to our day. And so I think that this can be taken to extreme or not be healthy, etc. That's another topic. For example, I saw a video earlier on X, which was a dog robot that they disguised in a little dinosaurus, and it was chasing some young kids, and the kids were playing with the dinosaur. It was very interesting to see how those systems can just create something new where human are receptive to like the actions and movements in an emotional connection with it. And the emotional connection to these things doesn't surprise me much. And I think that used well, it can be a superpower, but like everything that is a powerful tool, we must put guardrails into place and understand like problems, issues that can come up. Do you want to comment anything on that before I ask about like you as an educator?
what you said was that was debatable was actually a current question we have. We have a demo where the robot speaks. It can take pictures and make dances. And what it does is that it has a series of pre-recorded emotions that we call emotions because we try to record, like I have maybe 30 emotions that we did within the operation. And it can choose to play them simultaneously to anything else. So it could be telling a story, moving his head, face tracking you so that the interaction feels natural, and at the same time showing a bit of sadness if the specific moment was sad, or anger if the situation requires it. Well, we can also remove the voice and just keep some flute noises that we created for these motions. And it gives a completely different vibe. In a way, it's more, when it has like the flute noises, it looks like it's a pet, intelligent pet that understands everything you say, but cannot communicate with words. And when you activate the voice, it becomes like a human, like a AI agent. It's a bit different. I think we're just gonna provide a toggle and people will do whatever they want. But I'm very curious, how would people use it? What's the percentage of toggles for the voice versus flute noises? I don't know.
Yeah. The way I would see myself, I don't know, if I had a Reachy Mini in my back every time 24/7, I would be like, what do you think about that? So like I would want it to be connected to like all my devices and like he have a holistic vision as an agent of the situation. And I would like, do you agree? And we'd be like, doo-doo-doo-doo. And like you already know the sounds of like what validation or like and like the body moves.
You could see you go up and take that chocolate that you shouldn't take it.
Yeah, it's like no, not happening. You can build systems around your relationship. Like for example, if you do things or if you or like it connects to, for example, I have a Whoop here. It connects to my bio data, and so he can send me messages maybe like, hey, I'm seeing that you're doing that. So now we're not even talking about that body that I can see when I'm in the room, but like I'm touching on like a bigger agent that works with you. I'm just trying to drift with my thinking of what would I do with it. Maybe ask it to do things in my computer and like access, open a terminal. And what it does, it's like combine the action inside my computer with like some movement, like I'm down or like some things like this. And the emotion pieces, and I'm coming to a question to you, is that the interactions, vision, voice, sounds, combined with agents, how do you approach agentic behavior? The way I've seen it work, especially in web apps, is that, well, you have different endpoints and tools that you can call. And so I would assume that it would be the same in robotics, meaning that you build the backend, maybe with some framework and some tool calling. And then you just have to, when things happen, trigger the robots in the right ways and the right loops so that it is the continuity of that backend that you've built that lives in a server, maybe the same server that powers our little robot. But how do you approach that, building this agentic system? Maybe you've seen some systems already that people build that are interesting sharing.
No, but what you describe is quite accurate. I'd say if you get into detail, the details are, of course, there's some stuff to say. But yeah, the current state, in my opinion, is that an LLM, like we currently use GPT-4 real time, it's incredibly powerful to handle the high level decision. Well, it can't do like low level control of the motors. You can't just give it access to the motors and expect the robot to do something remotely smart or useful or harmonious. So what we do, that's our job currently, to provide a platform. What we define as the robot primitives are clean. Like the inverse kinematics is one of them. The control loop is one of them. Access to the sensors like the cameras and microphones is one of them. Where do you put the limit depends. Like something I changed recently, like in my life, I've written, I don't know how many state machines to kind of provide some life into it. But nowadays, you can just write a prompt to the LLM and give it agency to start idle behaviors whenever nothing is happening. So that's what happens with this conversational demo. The robot lives its life, and whenever it feels like, it can start to dance, play an emotion, speak, just breathe, take a picture and comment on what it sees. And 5 years ago, I would have been, hey, every 15 seconds, do one of these random. No. Now the LLM chooses. And for example, if the discussion we had previously was a bit sad, maybe the emotions that it will play naturally until the mood changes are more calm ones. So you get this super adaptive and smart high level behavior. But like the face tracking, for example, that's something that's completely solved locally, right? So you wouldn't rely on an LLM to handle something like that. That's your job on the back end to do. And then the details of that, we actually have, let's say, two main things that for the LLMs, like, he doesn't know, he just calls tools and stuff. But we have what we call the client, and we have what we call the daemon. Daemon handles the physical aspects of the robot interacting with the sensors, the inner control loop, providing commands and stuff like that. And it provides an API through a Python SDK. And what we build is a client that discusses with that. This is a client that discusses with the LLM, right? And then you can choose how much intelligence you put on the daemon side or on the application side. And we debated this, we iterated a bit, and we converged on the daemon side should be as simple as possible. It should do the simple things really, really well, control frequency, stable, super tested. And the more advanced things like the fusion of motions and face tracking, these are applications that run through the SDK. And yeah, once we add an MCP support, you could just speak to your robot. It integrates into your calendar, into your Notion page. It could be very powerful.
I love this. Just to make sure that I understood properly. So I see that there are multiple layers. A big part of what you've already built are like those continuous movements and sets of things that the robot can do, so that you abstract the complexity of that and people can, using that Python ANDK, directly trigger some specific actions for the robot. Do you confirm that, or would you add something to this?
Yeah, but you can connect at the level you want. You can send commands and spam them and do whatever you want. You can say, hey, I want to play an emotion. I want to play dance. I want you to look there. The head will go voot with an interpolation. I want to take a picture. I want to play a sound. All of those are things that are allowed by the Python SDK. Yeah.
So the Python SDK already has all of these built in, meaning that you do the hard work of talking to the robot and you already pre-designed this set of granular actions that you make it easy to access. So I imagine that someone that opens the Reachy Mini today can start by doing like the robot dancing, but then they can go deep into the client, into the SDK, so that they can combine things or create their own system and connect it to their agentic system to do more complex and advanced thing. And like when the MCP thing comes out, then you like have that would be fun. You can do a lot of things. And I really see your point to like, yeah, before you were adding randomness here and there with like numbers and it would do things trigger automatically. But now all of a sudden you can create a rule of thumb for a personality that decide which tool it's going to use and when. The spectrum is very interesting to move around and experiment.
Yeah, you just described it in a prompt, the personality, the behavior, like is. I still feel like a kid with this. Like in a few years, the way we interact with robots completely changed. When I was doing Robocop at home, there was a competition where you have service robots performing a number of tasks, like take out the garbage, empty the dishwasher, and whatnot. I think you could take the technology of today and go back 5 years in the past and just obliterate everyone in one afternoon of coding because we just plug, I don't know, Whisper for the voice recognition and LLM for the decisions, and the robot primitives were already working back then. So to me, we've lived a small revolution in robotics.
That's amazing. I think that there's a huge thing to comment on the robotic revolution with all of that. I want to double click on building robots. How does that look like in a team, but also at the technology level? Because I'm like being more web app, JavaScript, TypeScript, Python, and some common frameworks for like back-end, front-end things. I would assume that your tech stack and the tools that you use might be different. Also, I'm a heavy user of Cloud Code, Codex, Cursor, and all these latest tools. So how does that apply to robots and to your recent shares? There is a Python SDK, so that's different than when you're working directly on Reachy Mini and like all the robotic concepts that are behind. So how do you align engineering when working on robots, building agentic systems around them?
You wanted to know what is it like to build a robot? In my honest opinion, it's painful.
Okay.
It's painful because it never works until it does, but it's hard to get it. And why do I say that? It's because for a robot to work, you need everything to align. Everything needs to be robust. I think the key word of robotics is robust, because the mechanical design has to be sound. The electronics has to be working. The battery has to be charged. The cables are super painful. It's always the cable that are messing the robots up. The cables need to be working. The drivers have to work. The low level has to work. The middleware has to work. The high level has to work. The network has to work. And when you put it that way, you understand that if each of these steps has a 90% chance of working, your robot probably doesn't work at the end. Like you need to have much, much higher levels of robustness of each of these steps for the entire thing to work. And then what happens is it's very rare that a single person has knowledge on all of these things. By nature, you need a team and sometimes a small team, but to get an interesting robot, you need to have people of very different technical backgrounds, build something that's very technical, very fragile. In all of my competitions, I think on average, 50% of the robots did not start when they should have. They just didn't move. Like
Wow.
Even in a competition when the winner had $5 million, the second place had 2 million, and the third place had 1 million. I thought, okay, this is a super high level, best teams in the world. This time the robots will work. And I would say it was around 50%. 50% did not move. And it's just hard. It's hard. And the people working on these robots were really good. The likelihood of something going wrong is just so high that you need to have a very pragmatic, test-oriented view to get a successful robot. So that's one thing very important to get right, and to be comfortable with failure and iteration until you pinpoint what is the weak point of your entire process and improve on it. And then you get something that works. Regarding the technology, I'm already one of the old ones now. I get mocked a lot because I come from a more control theory background. So the inverse kinematics, I like to have equations and just describe them, an algorithm and stuff. The running gag is that sooner or later, all of that will be replaced by an end-to-end model. So an end-to-end model is the most disrespectful thing because you have a model, you provide it just the senses, it does its calculation, it provides the commands. So like the entire stack of I'll do the kinematics, I'll do the control, I do the planning, I'll do the image detect, everything, all of that. Years and years of study, let the model do it. And as far as I know, it doesn't work yet. There's a robot that says that it does it, but it's not open source as far as I know. So of course, it's a very active field of research. But the way we do it is that the low level, we do it the old way by hand. I think that's what most people do. Well, you can achieve very high frequencies, very stable behaviors. AI has access only to the high level decision for now. How will it change? Will it be like a slowly thing that goes and controls more and more in the technology stack? I don't know. For coding, however, the impact of LLM has definitely existed. I've been trying different tools over the years, now get a sense of what they're capable of doing and what they're not. In most cases, what I've seen is that LLMs are good at writing code that's clean for stuff that's well understood, well documented. That when you're reproducing something that's already been done several times, it will adapt to your use case, and in most cases, be a time saver. But whenever there's something a bit more abstract to understand, like the racing conditions and stuff like that, where a human will find a physical model of the world to understand what's happening and optimize for it. I've seen LLMs make tremendous mistakes, and it's hard to debug afterwards because the way they code is very fluent. Like it looks like it's nice. I think with complicated matters, we still need to be careful. We can't just relegate everything. But Codits, I've been using it like for a few weeks, and for some tasks like refactoring, and you have to modify many files on something that's not very complicated but annoying to do. I think is very good. And one question I have with that, and I don't know how to answer it, is what should we advise our students? Should you disable all of these AI tools and learn it the hard old way? Because when you're doing an exercise in school, generally any LLM will just ace the problem because it typically simpler problems. But if a student only does that, I'm afraid that their understanding of the technology stack will be a bit fuzzy. I'm never too sure what to advise because on the other hand, if the technology stays stable, you should use it. I still believe that it's important for the human brain to do stuff that is hard. You always need to try to improve on what you're doing. And specifically when you're young and you're a student, you should be learning stuff. You should be doing something hard. So that's something that I'm not sure how to handle it. I'm not sure how to handle it with my kids either. My conclusion for now is being conservative. If I don't know, let's do it the old way, because at least that we know how it goes.
I love that. Well, you shared so many interesting things. I have a personal opinion on that. And then I would love to wrap everything. And I definitely foresee like a second episode because I have too many things to ask. My personal opinion being, I think it's an hybrid, the answer. I think that what's great about those tools is that it can guide you like a mentor or a tutor to achieve what you're trying to do faster. And so if I can do more things in less time, then I can extract more learnings. And so I think that the way I would approach that is, what is my goal? And let's say I take robotic and I want to use a robot. Well, my first things, if I get a Reachy Mini, is I want to make it dance as fast as possible. This is like dopamine hit. And that when I'm hooked to the learning process, then I want to go on more complex thing. And then I will end up in a situation where my system is not working and I will need to know why. And so because I need to know why and the LLMs are not providing me, maybe they give me hints, then I will need to deep dive into the core concept. And so I think that it's a balance between on purpose, intentionally, balancing using those tools to build continuously and achieve results faster, and use them as tutors and reflecting on how did I get there, writing an article, a Substack about what did I build, how did I build it, what did I learn across the project, where did the LLM let me down and I had to find issues. And like the more I document and I use that to accelerate my pace of learning, because in the end, if you take robotics, what I love about what you share is the complexity of building the systems, the networks and the cables and the hardware and all of that. And the cool thing is that maybe you have superpower agents, but in the end, the direction you want to take the technology is yours. And so where it's going to fail, and it's going to fail, do you have the expertise to redirect or like fix or like understand what went wrong? And so I think that even if you put like the SOTA, the state-of-the-art people building robotics, you likely are one of them. Well, then all of a sudden they have this huge companion that can move very fast across the spectrum of things that can happen, debug in real time, check things. And so all of a sudden it's just like the more expert you get and the more you understand all the fundamentals and concepts, the better you become, because you can be very efficient about reviewing what's wrong, how to iterate on it, how to fix it, and you can even delegate those things. So this is my personal thought. Do you want to add anything on that?
I think I agree with what you're saying, and the way I would model this in my head is that when you're building a structure, when you vibe code something, it will move very fast. You will build something, but it's fragile. But it's interesting because you explore something super, super fast. I have 25,000 ideas with this robot, and I've been vibe coding many things, and I've been surprised at the high rate of success I had even on technologies I didn't know particularly well. So it's great to get a sense of what works. But if you want the thing to be stable, you need to kind of go back and solidify. You need to understand how it works, you need to test it, and it needs to be alive for a while. It needs to live and see different contexts. One of the typical things that happen with robotics, like it works somewhere, but then you change the lighting situation, you change the OS is running, you change the model of the robot, you change something, and it breaks. So for something to be really stable, it requires time and sometimes different people working on it. And maybe one way of doing it right, I think that's what we try to do, is like the building stones, they need to be super stable. And then that's super tested and doesn't change often once it is there. And then you build on top of that. And if your foundations are stable, it's likely that you're okay building something super fast. Even if that's not super stable, it should kind of work. And I have one example for this I find super interesting. It's like the dances I did. If you want to imagine them, the first idea just is sinus function on one of the control dimensions. For example, a sinus function on Z would be something like this. Okay, and then we could do a sinus function on roll. It would be something like this. And then you create a library with that where you can abstract what an oscillator is. It's not always a sinus, could be a different function, could be simple interpolation. And then you add a notion of combining these movements and with different amplitudes. And yeah, you treat the frequencies, tell them hertz, you call that BPM, so that's easy to interact with the music. And then you start creating functions like, okay, I want one where the head goes like this and the antennas goes like this, and you create a few examples. And what I noticed is that when I gave that to an LLM and I described in natural language, hey, I want you to create a new dance that expresses this and that, or kind of describe the movement, it worked super well. And then a large percentage of the following functions were completely created that way. And it's very easy to test because you can just run it and see what happens. It's very safe because it uses a very restrict number of tools, which is the oscillators and the stuff that you define. And in a way, what happened there is that we created a kind of a new language that is a symbolic description of a movement. Symbolic just means that there is an equation that describes the movement. And the LLM is super good at translating between your natural language and this new symbolic language that the robot kind of understands, the sinus and stuff. And I've been almost shocked at how well it worked. I think you can just say, hey, I want you to create a series of dances for this music, and just give the name of the music, and it will know the general feeling of the music and create a series of functions that work. And I started a student project on this. Okay, how do you create motion that has emotion in it, that has purpose? And one of the ideas is let the LLM generate code as it comes and play it. Of course, there's a tremendous security issue there. You have to handle that. But that's super interesting. Yeah.
I love this. Well, Remi, that was awesome. I want to be mindful of your time, but I definitely foresee a second episode because I have too much question to ask. And just to wrap up this episode with all the amazing topics that you've discussed. So you are currently launching Reachy Mini to a closed set of users, and soon later, possibly this year or the next year, you are going to see like a bigger launch to everyone. Anything that you want to plug, your YouTube channel, where can people follow you? What are the next launch going to be? Any information that you feel like sharing? Maybe you're hiring.
We're currently not hiring, but I mean, you can always apply something. There's a perfect alignment. It could happen. That's for the robotics part. For the rest of the workplace, I don't know. And Reachy Mini has already been released the commercial release happened already. Is the physical shipping of the robot that will happen in a few months. So now we had already a lot of sales for the robot. I could just say, try to follow us, see if our things work, how people work with it, what they build. Personally, I'd like teachers to use the platform, even if they're not using the physical one. We'll provide the simulator and everything will be open source and free to use. I think the software interfaces are simple, so that you can build whatever you want. If you're doing an RL course, a kinematics course, a vision course, I would really like it if I had feedback on, hey, I used that and it was useful. I would be very happy. And yeah, now we'll see. We'll see what the future holds.
I'm so excited. I'm on the wait list for sure. I'll do some cool tutorials. I'll explore all the concepts that you share with me and I'll create a course with it. Remi, thank you very much for taking the time to join on the pod. I look forward to all the next videos that you're going to share, and have an amazing day.